This video is on quadratics review. We're going to be focusing on graphing and the important information. We have two problems where we're given the equation. We want to find all of the important information in our chart, and then we want to graph them. So for this first example, we're going to do everything by hand. In the second example, I'm going to do it in the calculator. So our first example is y equals -1/4 parentheses x plus 3 squared plus 1. This is actually in vertex form because of the format. This will automatically give us our vertex then. Our vertex, so down here in our chart for vertex, is a coordinate. We have to remember to change the h value of that 3, so it's really a -3, comma. We keep our k value of 1, so our vertex is at -3, +1. So from this one coordinate, we can actually answer a lot of information. We know what our axis of symmetry is because the axis of symmetry is that vertical line that goes through our vertex, and a vertical line is always an x equals. So our x equals -3. That would be our axis of symmetry because that's the line that goes through that coordinate. I'm not going to answer my y-intercept yet. I will determine if it opens up or down by looking at the equation. Since that a value here is negative, this graph is going to open down. I'm going to put it opens down. I'm going to make a note because a is equal to a negative. From here, I can answer almost everything here because of my vertex and my a value. Because my a value is negative, because it's opening down, we're going to have a maximum. The maximum comes from the vertex, so that's why vertex form can give you most of the information. The maximum value will actually be at that 1 because that's the highest y value it can go to. The domain of quadratics, because it's a parabola, is opening down, it'll keep going to the left and to the right forever. So our domain is from -infinity to +infinity. And because they will never actually hit infinity, it's not an actual number, we're going to have what's called open brackets because they will never actually stop. Our range is our y values. Since the y values since it's opening down, the y values will keep going down forever, so it'll go towards that -infinity forever, but it'll stop when it gets to that top point. So it's not going to keep going up. So it will not go to +infinity. It will go to that -infinity, and because the a value is negative, that tells you that you're going to have that -infinity for the range. So the -infinity is always written on the left-hand side, but the right-hand side will not be +infinity because it will not keep going up. It's going to stop and then come back down. That stopping point that it gets to is that value. That's the highest y value it'll reach. So it'll hit that 1, but then come back down. So again, -infinity will never actually technically be reached. So that's why it's going to be an open bracket. But that 1 will be reached and then come back down. So we're going to have a closed bracket on there because it will touch that 1. Most of this information is easily found from the vertex. Okay, so now we have to find the x-intercepts and the y-intercept. Remember, x-intercepts come from the factored form and the y-intercept comes from the standard form. So we could convert these. We could convert this to find those, but that would take more work. So what we're going to do, we're going to find the y-intercept first. The y-intercept is when your x value is 0. We know it's a 0, a number. So let's find our y-intercept. I'm going to write it out over here. Y-intercept is when x is equal to 0. We are given the original equation, which has a y and an x in it, but we'll know what that x value is because it's going to be 0. We need to find the y. So we can just plug in 0 for that x. So the y will equal to -1/4 parentheses. 0 is going to go in for that x. So I'm going to put 0. Then we're going to keep everything else the same. +3 parentheses squared plus 1. I just want to figure out what this value is. So I'm going to go to my calculator. I'm going to type in negative 1/4. It's a fraction, so I'm going to put parentheses around it. So parentheses, negative 1/4 parentheses, just because it's a fraction. Then I'm going to type in everything else the exact same. So I have parentheses, 0 plus 3, close parentheses, squared, then plus 1. I'm not graphing this. I'm actually evaluating it, so I'm going to put it into the home screen. I'm going to press enter. I get negative 1 and 25/100. So I have y equals negative 1 and 25/100. Or negative 1 1/4. So my y-intercept is at 0, negative 1 and 25/100. So I'm going to go ahead and graph the vertex and graph the y-intercept. My vertex was at negative 3, positive 1. We need to go ahead and put the x and y on our axes. We already know what they're counting by because we already have the scale on it. Do need to put in here the axis of symmetry, which is that vertical line that goes through that vertex. And we know it's going to open down from our vertex, so I'm going to label it as AOS, x equals negative 3. We also have our y-intercept was at 0, negative 1 1/4, so 0, negative 1 1/4 is about right here. Now I can actually, because we have our axis symmetry, I can mirror this coordinate on the other side. So I can go 1, 2, 3 steps away. Then I can count 3 more. 1, 2, 3 steps away. So another coordinate would be at negative 6, comma, negative 1 and 25/100. So my x-intercepts should hopefully be at negative 1 or negative 2 because it would graph like this. So I'm actually going to try, again by hand, to find my x-intercepts. I'm going to use negative 1 first. So I'm going to go down here and type in x equals negative 1, just like I did for the x equals 0. I'm going to type in the negative 1. So I'm going to have y equals negative 1/4, parentheses. Instead of the 0, I'm going to put in that negative 1 plus 3, parentheses squared, plus 1. So again, I'm going to go to my calculator. Type in, I have a negative 1/4, so again, I'm going to put that in parentheses because it's a fraction. Negative 1/4. Type in everything else the same. So parentheses, negative 1 plus 3, parentheses, squared, plus 1, and I get 0. So this actually is the x-intercept. When y is 0, you have your x-intercept. So let's go and graph that to find our other one as well. So negative 1, 0. We can mirror it across the axis of symmetry to find our other one. So we have 1, 2 to the axis of symmetry, so 1, 2 away. That's at negative 5, 0. So our two x-intercepts are actually at negative 1, 0 and negative 5, 0. Those are our two x-intercepts. So we have our 5 coordinates, so we can actually connect these and just extend it. Remember, you always want to extend it as far as you can and put arrows on them. So that one is done all by hand and using our calculator to plug stuff in, but we found all of the coordinates by hand and we were able to figure out everything just from vertex form. On the second example, we are actually going to find everything in our calculator. So on this one, we're given, this does not have a squared on it, but it does have parentheses. So that's actually in intercept form. This is intercept form. So this tells us our two x-intercepts. So let's go and find everything. We're going to go to our calculator. I'm going to graph this. So I have negative 3x, parentheses, x minus 2, close parentheses. I'm going to press zoom standard, see if I can see stuff. Alright, so we do have a vertex. That vertex looks to be at about 1, and that might be at 3. So let's go to our table, because if you see, we're actually kind of looking for the tables of everything. Okay. Second table, and we thought that it was at maybe 1, 3, and this actually is at 1, 3. But you can tell that this will be our vertex because above and below that 3, these numbers are repeating. So you can see that the vertex, this number, is in the middle of these coordinates. These are all repeating. The y values are repeating. That automatically tells you that that is, in fact, your vertex. So our vertex is at 1, 3. So since we can find our vertex, we can answer all of these, the same things we did over here, just from the vertex. So our axis of symmetry will be x equals 1. Then we'll go to, does it open up or down? And we can actually go back to our graph. That's opening down, so we can answer down. And you can also see that because our a value, the very first number, is a negative. So a is equal to a negative. Since it's opening down, we're going to have a maximum. And our value, again, comes from that y value of our vertex. That's that value of 3. Our domain, again, is going to be that negative infinity to that positive infinity because it's going to go left and right forever with open brackets. And then our range comes from the y values. Now again, since it's opening down, it will go down forever, so the y values will hit negative infinity. And that negative infinity is always written on the left. But it'll go up to that 3 and then come back down. That's why we want that value. So we'll go up to 3, but then come back down. So open bracket on negative infinity, but then close bracket on that 3. So let's go and find our y-intercept and our x-intercepts from our table. So second table again. X-intercepts are when the y value is 0. So that y value here of 0 and the y value here of 0. So we have two x-intercepts. One of them is at 0, 0. And the other one was at 2, 0. Our y-intercept is when the x value is 0. So I'm going to come over here, the x value of 0. My y-intercept is at 0, 0. So now we have all of the chart. Let's go and graph this. Put the x and y on our axes, and we already have our scale. So our vertex is at 1, 3. So go ahead and draw in your axis of symmetry as well, that vertical line going through that vertex because everything is symmetrical across from it. We're going to label it as AOS x equals 1 because that is our axis of symmetry. Then we're going to graph our two x-intercepts at 0, 0 and 2, 0. But we need two more coordinates, and we don't have any more coordinates on here, but we can still look at our calculator, and we have multiple coordinates. I cannot graph that negative 2, negative 24 because it only goes to tens, but I can graph that negative 1, negative 9. So negative 1, negative 9 goes here. And I can just mirror that to the other side. So I count 1, 2 to the axis of symmetry, and then 1, 2 more. That's actually at 3, negative 9. And I can check a coordinate is at 3, negative 9. So that is good. Now we have 5 coordinates. We can connect them. Put arrows on the ends. And there's our graph. Now, I do want to mention that since this was intercept form, we could have found our x-intercepts as soon as possible. This x value, I set that equal to 0. So x is equal to 0. This x, I set this equal to 0 and solve. So I would add 2. So x would equal to a positive 2. X was 0, x was positive 2. Those were our two x-intercepts. So that's graphing it and the important information.